day, mate. I don't know what's going on, Peter. You're late, mate. Any questions? You can comment there. Miss Lake, Demo, you can comment. Ben Twala, you can comment, you can comment, you can comment if you have any question. If you're happy, you can just show a thumbs up or yeah, say something. And please don't say anything outside the syllabus, ne? Please. Okay, Fere. So we're good, we're good. So yeah, so why is it important for us to why is it important for us to generate this so-called cumulative frequency polygon? Like, why do we do it in the first place? Why do mathematicians why did they decide to sort of make this thing a thing? This is how we use it. This is the reason why we need to learn it. If I when I asked you guys, or how many learners got a mark of 60 or less, ne? You guys said 6 learners. Why? Because you took the 2 from this first interval and the 4 from the other interval, and then you guys said 6 learners got a mark of 60 or less. Now, this cumulative frequency polygon also helps you to find the number of learners who got a 60 or less. How to do that is, if I ask you what is the number of learners who got 60 or less, you go to your x-axis, you look for 60, here's a 60. You draw dotted lines from the 60, yeah, from the x-axis, dotted lines vertically up until you get to the graph itself. Once you touch the graph, you then extend the dotted lines straight to the y-axis. Then this value there, where the dotted lines land, this value is the number of learners who got a mark of 60 or less, and that happens to be 60, which is consistent with our table there. You guys see the significance, or how we use the Ogive? Yeah. So we use it to answer such questions. I'm gonna do another example on this. If they ask you how many learners got a mark of 80 or less, okay, let's start by using the table. Yeah. Remember from the table we said, I'll start from basically do a summary. Remember from the table we said we were looking at the marks of 10 learners in a class. Okay, we established from the data that 2 learners got a mark of between 20 and 40. We had 4 learners who got a mark of between 40 and 60. We've got 3 learners who got a mark between 60 and 80. We only had 1 learner who got a mark between 80 and 100. Okay, so we established that, and then after that, I asked you guys to create, or we created another column called the cumulative frequency column. Ne? So what is this column for? So this entry, we're going to fill it with the number of learners who got a mark of 40 or less. So you just focus on the upper bound of the interval. Ne? So in this cell, we put the number of learners who got a mark of 40 or less, which is obviously 2. And then on this cell, we put the number of learners who got a mark of 60 or less. So that's obviously this 2 and that 4. So it gives us a 6. Then in this cell, mark the number of learners who got a mark of 80 or less. That's literally that 2 plus 4 plus 3 gives us a 9. Lastly, this cell we populated with the number of learners who got a mark of 100 or less. That's essentially like all of this. You just add all of this, gives you 10. Okay, sharp. And then we eventually drew this cumulative frequency thing. How do we draw this graph? We draw points, right? We use the upper bound of the interval as our x coordinate. So this will be the x coordinate, and then this value will be a y coordinate. The upper bound there, 60, will be an x coordinate. Then this value there will be our y coordinate. And then our 80 x coordinate, the 9 y coordinate. Lastly, the 100 x coordinate, then the 10 there, our y coordinate. We plotted these points sharp. Then I asked the question just now, how many learners got a mark of 60 or less? We established that is of 60 or less, that is 6. You could also use the frequency polygon, or cumulative frequency polygon, also known as the Ogive, to find that value. How do you do it? You go to the x-axis, you look for 60. There's our 60. You draw dotted lines vertically up until you get to the graph, and then extend the dotted lines to the y-axis. Wherever this thing lands, that's your number of learners who got a mark of 60 or less. Let's look at 80. How many learners got a mark of 80 or less? Let's use the Ogive. You go to the 80 there on the x-axis, dotted lines straight up until the graph, extend the dotted lines to the y-axis. This gives you a 9. So that's why even on our table there, we got 9. Okay, lastly, number of learners got a mark between, sorry, of 100 or less. Go to 100 there, dotted lines, 10. We get the same answer there from the table as well. Easy peasy, ne? Any questions? Any questions? Easy, Boza, easy. Siana Pizza, do you get it? Amo, do you get it? Kopano, easy, ne? Gosnati, easy, ne? Proper stuff. Proper stuff. Proper stuff. Okay, so that's the whole point of the cumulative frequency polygon. That's the graph you see in front of you, also known as the Ogive or Ogive. However you pronounce it depends if you speak British English or you speak American English, so just or South African. South African. Okay. So let's just quickly do another question. If they ask you, ne, okay, let's do this. How many learners got a mark between 40 and 60? We already established that that's 4 again. It's 4 learners. Okay, sharp. Sharp. So now a question comes ne, and asks you, ne, using the diagram, using the graph, the Ogive or Ogive, how many learners got a mark between 60 and 40? You don't have, let's just assume that you don't have this table. Ne? How would you find that? You do this, ne? You do this. So how many learners got a mark between 40 and 60? So you do this, you go to 40, the minimum bound, ne? Or the lower bound, sorry. You go to 40 there, dotted lines, 2. So this is a number of learners who got 40 or less. You keep it. You go to the upper bound, 60, dotted lines. 6 is a number of learners who got a mark of 60 or less. Okay. So now if you're looking for the number of learners who got 40, between 40 and 60, you're going to take this number, 6 minus, take this number there from the minimum bound, 2, gives you an answer of 4. Matches our answer from the table or our value from the table. Any questions? Please ask questions. Wakushisha, remember you're free to ask questions in Sizulu, in Sepedi or Afrikaans or any language you know, feel free or tusha. Do you see how important and how flexible the cumulative frequency polygon is? Ne? K. Let's do another question. Similar question though. How many learners got a mark between 60 and 80? From our table, we can clearly see that is 3 learners. I'm going to explain slow. 3 learners from our data. Okay? Already established that. So how do you use the Ogive or Ogive to find this number 3? So we're just assuming that we don't have this table. We're not given an exam. They just give us this graph, this Ogive, and ask us to find number of learners between 60 and 80. So this is how you find it. Very similar to the question we just did. So you look at the minimum bound, which is 60, or the lower bound, 60, dotted lines to the graph, dotted lines, 6. Okay. So now this 6 is the number of learners got 60 or less. You keep it. Now let's look at the upper bound, 80, dotted lines to the graph, to the y-axis, 9. So this 9 is the number of learners who got 80 or less. That's fine. But now the question is asking you to find the number of learners between 60 and 80. So you're going to take this number, then subtract this number. So you're going to take this number minus that. So it's 9 minus 6, which gives you an answer of 3, matches our diagram. Okay? Yes. So now, I'm going to, let's see if I've got another diagram on the Ogive again. Yes, I've got it. Okay, let's just clear this. Let me clear the space quickly. Let us clear the space there. Okay, just bear with me. My whiteboard is frozen. If they ask you how many students got a mark between 80 and 100, okay? So that's clearly 1 we're given there, but let's just assume we're not given that in the exam. So let's use our Ogive to find that value. So you look at the minimum bound, that's 80. You go to 80 dotted lines to the graph itself. Extend the dotted lines to the y-axis. That's around 9. Then the upper bound, which is 100, you go to the x-axis, dotted lines up, extend the dotted lines to the y-axis, gives you 10. So this 10 means that, or rather gives you the number of learners that got 100 or less. This 9 gives you a number of learners that got 80 or less. When are you looking for the number of learners that got between 80 and 100? So just simply take the 10 there, minus the 9, gives you 1. Matches our value there, ne? Easy peasy lemon squeezy. Sharp. So now I'm going to do a summary of the session so that you guys understand exactly what we did, okay? I'm going to give you a nice, young, quick summary of the session in closing. Okay, I'm going to start from scratch. So it's just a summary, yeah? So when I started the session, I told you already, in this session, we're going to be covering what we call the histogram and the ogive. Okay, so this is like a topic you're going to get taught in term 3 when you open under statistics, grade 11. Okay, sharp. So now I always use examples in my sessions when I explain concepts. Okay, so I asked you guys, Hore, we're going to use this example. So we're taking this data, 10 students write a maths test, and they later got their marks published, okay, on some notice board or something. So you've got 10 learners here. Here, they are the names, and then these are the respective marks. So this learner got 24, 35, 53, 52, and so on. And the highest performing learner got 95. I don't know why I put that name there, but yeah. So it's like, yeah, 10 learners, each mark out of 100. Okay, fine. Now, then I asked you a series of questions. I asked how many learners got a mark. Question A, how many learners got a mark between 20 and 40? Then we established that this person and that person got a mark between 20 and 40. So that's 2 learners. So I put a 2 there. And then I also asked how many learners got a mark between 20 and 40 and 60. That is this one, and that one, and that one. So it's 4 learners. So we put a 4 there. The next between 60 and 80, we've got 1, 2, 3 learners. And then between like 80 and 100, we've got 1 person. So we put 1 there. Okay. So now this is the data we have. So now then I said that let us draw a table from these values here. Ne? So I'm gonna write an interval and its value, right? So we did that, and we got this. We got that the number of learners who got a mark between 20 and 40, there's 2, 40 and 60, 4, 60 and 80, 3, 80 and 100, 1. Fair, that's fine. Now, this looks like a sentence, man. It doesn't look mathematical. So I said that let us change this thing and put it in a math format. Okay, so that's called what did I call it again? I forgot the name, the technical name, but yeah. So instead of you writing 20 between 20 and 40, write 20 and 40 brackets like that, ne? And then the convention is that for the lower bound, ne, you draw a curly bracket, and for the upper bound you put a square bracket. This means that we include 40, we exclude 20. So if, for example, someone got a mark of 20 ne, in the class, ne, you can't include them in this interval because 20 is excluded there. Okay? That's what this thing means. If someone had gotten a 40 in class, then we would include them in this first interval because 40 is included there by way of the square bracket. Is that clear, Kopano? Yeah, kwagala mfiti. Yeah, bona. Yeah, kwalake. Yes. Easy. Yavakala matot. Yavakala. Okay, sharp. So that's what we did. So we put all of that information into another table. This table over here, easy peasy. And then after that, we drew a graph from this data. We drew a bar. We started by drawing a bar graph. Okay, from this data. So let's quickly show you where we drew the bar graph. Here's our bar graph. Okay, on the x-axis, we put the intervals, as you can see, 20 and 40, 40 to 60, 60 and 80, and so on. And then on the y-axis, we put the number of learners in the interval. Okay, so like for the first row or the piece of first interval, we've got between 20 and 40, we've got 2. 20 and 40, we've got 2 there. Between 40 and 60, we've got 4. 40 and 60, we've got 4, and so on. Okay, this is what we call the histogram. We did that in grade 10 and also grade 9, right? So then from this piece of information, again, you can also draw another type of sort of graph. We call this the frequency polygon or the line graph, so to speak. So it's literally the same thing, but just put dots. Instead of you putting like bars, just put dots like that and join them like that. Okay, so this is what we have here. Okay, instead of you writing the number of learners in the water, just write frequency. It's just the same thing. This is what we have there. This is what we call the frequency polygon. Okay, and then after that we moved. Here's our frequency polygon. I redrew it and removed the bar. Redrew everything, removed the bar. So I essentially removed the bars, so not the bars, but the bars. I removed these things so that we have the line, the line graph itself, the frequency polygon. Okay, that's about that. Nothing complicated. Then I asked you guys, let us draw another from our table. Let us draw another column. Ne? What we have in this column for the first cell in the column, we call this a cumulative frequency column. So what do we have in that column? For the first one, what do we have? We have the number of learners that got a mark of 40 or less. So it's clearly 2. We put 2. The number of learners got 60 or less. So this includes the number of learners in this interval plus the one lower. So therefore, you just add these two numbers, you get a 6. Then the next cell, we put the number of learners that got 80 or less. So it includes learners in this interval and the intervals below. So just simply add everything here. Gives you a 9. Do the same for the last one, you get a 10 there. And then after that, from this piece of information, let us draw a new graph. Okay, so so essentially this is a new column. Okay, then we're gonna draw a new graph from this new column. How are we gonna draw the new graph? The x coordinates of each of the points will be the upper bound. So for the first point up, our x coordinate is 40. Our y coordinate is this number there. Our x coordinate 60, y coordinate this number there. 80, y coordinate 100, x coordinate, y coordinate 10. So we drew that. Okay. Put our points there. On the y-axis, we put the cumulative frequency on the x-axis, the interval. Now, you should also obviously join the points, and after joining the points, your graph must start like at the x-axis. And how do you extend it? You extend it like this. You look at the lower bound of the first interval. That's 20. You draw it from there. So therefore, it's gonna start here at 20 like this. So your graph will have this S shape, letter S shape. That's how it should look like. So this is what we call the cumulative frequency polygon, or for short, Ogive. Easy peasy, ne? Yes, so that's it for the session today. I hope you understood everything. So from tomorrow, we're going to continue from here. We're going to do some more statistics topics for grade 11, okay? So please make sure that you join in time. Don't join at 10 past 5 or whatever. Make sure that you join at 5 o'clock on the dot, ne? So yeah, that's the session for today. Let's meet again 5 o'clock. And then those of you who are probably watching a live from TikTok, please contact me so that you can join our class on a permanent basis. So this is just temporary that I also shared on TikTok, but yeah, please do send me a message on WhatsApp, ne? On the given number so that I may add you on the group and then you make the necessary payments. Okay. So we also have our textbooks. I don't know if you guys have noticed all that you see here, all of these diagrams here, I took them from the Rakhov Education textbooks. So we've got the grade 10, grade 11, and grade 12 textbooks, right? So if you order today, you send me your delivery address, and then we deliver your book within 6 days, okay? Straight to your doorstep, okay? Not via some other platform, but straight to your house, okay? So yeah, thank you so much. Let's meet again tomorrow at 5 o'clock. God bless you and your whole family. Ngiyabonga.